Maybe we should watch.
I turned it back on. I turned it off.
Okay, ladies and gentlemen.
All right, I can finally start my project here. I'm doing my project on biocontainment and biosafety as it pertains to global health. So first off, what is biocontainment? It's essentially laboratory safety when dealing with biological materials, pathogens, bacteria, viruses, any organic substance that can cause pathogen, or that is a pathogen, cause disease. And its primary goal is to spread infectious, or is to prevent the spread of infectious disease to people and the environment. So the kinds of things, or the kind of people that rely on biocontainment are scientists, medical professionals, and everyone else to a lesser extent. Scientists because they work in labs using biological substances like pathogens. Medical personnel because they work with biological substances like blood and other bodily fluids, and they have to make sure that they don't contaminate anything, and if they do contaminate anything, that they follow the proper procedure to sterilize it. And anybody, it's just common sense to wash your hands when you sneeze and cough and whatever, or when you share something that's used by a lot of people, like tables and things. You wash your hands to prevent infectious disease. So what biosciences use as a gauge to measure the level of risk that biological substances pose as pathogens are biosafety levels. There's 4 of them, and they're ordered from least to greatest based on the severity of the disease and the available treatment for it. So if there's no treatment for it, then it is a very high risk because you can't get care for it if you're exposed to it. So it also determines what we need to do to ensure that a laboratory is safe and contains any pathogens. So biosafety level 1 is the least risk, and we actually can work with things that fall under biosafety level 1 in this classroom. So we need to disinfect surfaces in level 1 facilities, hand washing, wearing lab coats, eye safety, gloves. We have an autoclave, which is very useful for disinfecting and sterilizing things with heat. And there's very little risk to the people involved, like us, because the substances we use are not known to cause or unlikely to cause pathogens, unlikely to cause infectious disease. So they're well documented and characterized substances and organisms. And we have examples of that. We actually used non-pathogenic E. coli when we did our plasmid lab, and it's growing right there. So we can work with these things because they aren't a direct health risk to us. So canine hepatitis, we're not likely to transmit that, and we're not likely to catch it because it's not a disease that affects us. So one level higher, we have biosafety level 2. This requires more training involved when you have a facility with level 2 pathogens. So we need more supervision, so we need more experienced people making sure that we're following the procedures correctly. It has restricted lab access, so anytime people are doing a laboratory which works with pathogens, there is no public access to the laboratory. And safety cabinets, which I'll talk about a little bit. Safety cabinets are essentially the self-contained laboratory setting, so a box in which you can work with samples without any risk of them spreading around the lab. And sharps are the next big thing to worry about, because if you get puncture wounds or anything like that, that's the highest risk of really getting these level 2 pathogens spread to people, because they're not usually airborne, and they're not usually able to live on surfaces that well, because that's how we characterize them. They're not easily spreadable, but they will spread quickly if you stab something with them on you. And genetically modified organisms like genetically modified plants and animals are also considered biosafety level 2, and that is because we don't want them to mix into the ecosystem and cause unforeseen results like cross-contamination of genomes. And we have examples of biosafety level 2 organisms: salmonella, influenza, hepatitis, Lyme disease, dengue fever, HIV is one of them, measles and mumps. So we have some influenza right there and its structure. Biosafety level 3 is more exotic. It's a lot rarer to come across biosafety level 3 facilities and laboratories, but that's because they're really dangerous organisms that they usually work with. And what characterizes biosafety level 3 organisms is that they're often transmitted in the air, so they're aerosol, or you can breathe them in and will likely pose a risk of infection. So they have special practices in these labs where you get the standard microbial practices, which involve all the disinfectant stuff, as I said before, in the safety equipment guidelines, which are really, really strict about wearing all the equipment that protects you from infection while in the lab. And we have examples like anthrax, West Nile virus, SARS, yellow fever, more advanced strains of salmonella, and salmonella typhi. And there's the salmonella part of the study. Biosafety level 4 is the highest risk facility, and it is exclusively aerosol-borne diseases. So if people were infected with this, them breathing is just a risk of infection to others. So it's a highly quarantined room or environment that biosafety level 4 organisms are kept in. And that means that in the laboratories, you must wear a hazmat suit, and the entrances and exits have showers. There's a UV light bath to kill things with UV radiation, a vacuum room, and airlocks, and they actually keep the whole facility under slightly lower pressure than the outside world. So if there's any leak in the facility, air will come in rather than go out. Yes.
Oh, what's a hazmat suit?
Hazmat is a hazardous materials suit, and it's essentially a big, airtight rubber suit that you wear with a breathing apparatus on it. So you can go into any environment with less risk of aerosol or chemical exposure. Examples of biosafety level 4 are the Ebola virus, Lassa fever, Crimean Congo hemorrhagic fever, and smallpox, as well as Marburg virus. And a lot of these we've worked really hard to contain and wipe out. So smallpox, these diseases are kept under the strictest conditions to make sure that they don't re-emerge into the world, basically. Good question.
What's Ebola virus? I feel like I've heard that before.
Ebola is another kind of, I believe it's another hemorrhagic causing pathogen. So it causes basically like bleeding everywhere where there's soft tissue. So your eyes, your nose, your ears, your mouth. Not a fun virus. So here's the activity. If you guys want to do this over the weekend, I think we can.
You got time?
We got time?
You got time.
All
You have
right,
20
then.
minutes.
Okay, so if you look at your primer there, the one with the box, it describes hypothetical, or it describes the category B biological substance shipping procedure or definition. And so what that is a substance which is being mailed that is a biological threat, basically, is regulated through the mail with a procedure that makes sure that it's easily visible as a biological material and that it does not basically leak into the outside world. And it has a picture of the box that they use to ship the containers, and there's a list on the second sheet that includes all the features that you want to have or consider when shipping something. So in this, we're having a hypothetical substance, category B substance in liquid form that I want everyone to draw a picture of, just a containment vessel of some kind. I won't tell you what it is because that's kind of up to you to consider. What would be the best way to keep this substance from contaminating outside of its container? So if you guys would spend 5 or 10 minutes maybe drawing this. And,
Should they draw it on the back of this?
yes.
Draw on the back of which one?
Just draw on the back of either one, whichever one you want to use, in case you want to read the other one while you draw.
So this is biosafety level 3, right?
Mm-hmm.
We're doing?
It's a biosafety level 3.
Can you go back to that slide? The 3? There you go. Next one. So just people have in mind what the
examples are this one.
examples, I think. Next one.
Okay.
Choose one of those and make your
Yes, anthrax. Yes, we're transporting anthrax or SARS or West Nile virus or something other. They are in a liquid form, so you can transport the liquid in any kind of. You can do anything you want to, anything at all, just as long as they do not get at it. But they must arrive intact.
So does that say like the box?
It must fit. It just has to fit in that box. That's all it has to do.
It has to fit. Can we draw next to the box?
Not enough room. Yes, you can.
Yeah.
So you guys can talk amongst yourselves. This can be done in groups. I'm fine with it. You guys can consider ideas to include. The more the better, really. The more precautions to prevent the spread of anything